Alright, so this week we're gonna get into Lab 2, which is your dial calipers. So this is what a typical dial caliper looks like. So in this lesson we're gonna get into 4 types of measurements that dial calipers can perform, and then we're gonna identify the different parts of a dial caliper, and then we're gonna learn how to actually read an inch dial caliper. Of course, dial calipers are very common. They're very versatile measuring tools. Engineers, your technicians, scientists, machinists, they use them, okay, for precision measurement every day. We do analysis, inspection, engineering, design, reverse engineer, manufacturing, so and so, and we use this tool. So the calipers, we use them to measure parts, and we can do 4 types of measurements. So the very first one is the outside thickness, either diameter or object thickness, but the outside, okay? Then we can measure inside width, again either diameter or inside space. Then we can measure the step distance, and we can also measure the hole depth. So outside measurement, you can take a look at it, and this is how we put the part in between the dial caliper to get the measurement of that. And this way of measuring the part, and we call that the outside measurement. So when you look at the instrument caliper, you can see there's 2 faces. See that? So that's where the part is gonna go into, okay, in between the 2 faces. So that's, we call it the outside measuring faces. For inside measurement, look at this top part, and that is your inside measuring faces. And if you want to get the measurement of this hole, you're going to just insert the dial caliper inside measuring faces into the hole, okay? And then of course you adjust the instrument to be able to measure the entire diameter of that hole. So by measuring in this way, we can get the space, okay, the width of this space. So, its diameter. We have, of course, many different kinds of holes, and of course inside spaces that we can be able to measure with this tool. And the next set of faces is right here, and that's, okay, the step measuring faces, where we can be able to measure the step. See that? So that's a step parallel surface distance can be measured in this way, okay? Inside and then outside, and this is your step, okay? Step measuring face, you put your part, and then you can be able to measure the step on that part, which is a feature of that part. So that's a pretty convenient way to measure. Then we're going to use the depth measuring faces, which is here, to measure the depth of a hole. So just here, this is section view, so you can be able to see, okay, inside of that slot, and we're putting the depth measuring face, which is actually this part, into that slot, and you can be able to measure the depth of that, okay? So the width you can measure with the inside measuring faces, okay? Outside part, we're going to use the outside measuring faces, and then of course the depth, we can use the depth measuring faces. Okay, when we come into nomenclature or the terms, so this is your inch dial caliper, okay? Of course we go by inch, so you can be able to see, yeah, the scale right here on the dial caliper. See, starting from 0 and then go 1 inch, 2 inch, 3 inch, of course. And the reader is going to be right here. Yeah, this is where your scale is, and whatever you're measuring, your inside part, outside part, and the depth. Okay, we can be able to adjust this scale, and we will cut it out right here. Okay, so this is how we use this tool. So nomenclature, the very first one you have to learn is this is called the inch dial caliper, and a standard inch dial caliper is going to measure slightly more than 6 inches. Okay, so that's its capability of that instrument. When you look at this, this is called the blade scale, and it shows you each inch right there. So 1, 2, 3, 4, divided into 10 increments. See, so 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and like your steel rule. Okay, so you have a 10 increment, and then go 1 inch 10, 2 inch 10, and then 3 inch, and then go 10 increment, and you're gonna get your 4 inch. Okay, and then go all the way to 6. And each increment from here to here is equal to 0.100 inches. So that's a 100,000 of an inch. Okay. And this is your dial caliper, and the blade goes here. Yeah. And blade is the immovable portion of that dial caliper. Slider, this is going to move, yeah, along that blade, and is used to adjust the distance between the measuring surfaces. So you have one pair inside, outside, and then your depth is right here, yeah, and your step is right here. Pointer, so the pointer is going to rotate, of course, within the dial as your slider moves back and forth along the blade. Okay, so the slider is going to move along the blade, and then your pointer is going to rotate, so we can be able to see the second scale. Okay, so followed by the first, so your primary scale, and then the detail scale is going to be here. Yeah, so that's how accurate this dial caliper is. And here is your reference edge. Okay, make sure you carefully look at the reference edge because it's very small, so it keeps track of your larger increment, okay, which is 0.100 in scale, and then the slider is going to move along the rack. Of course, the inside scale, which is your pointer, is going to give you the small increments, okay, to complete the accuracy. And the gear to rack is used to change the linear motion, which is your slider, and you can change it to the rotary motion, okay, which is your pointer. So this is called the rack. Okay, let's get into how to read the inch dial caliper. So the dial is divided 100, okay, times with each graduation, which is about 0.001 inch. Okay, so that's very tiny. So that's a 1,000 of an inch. So some dials also show half thousand. Okay, so which is half of that. So 0.001 divided by 2 is going to give you 0.0005 graduations. Okay, so every time the pointer completes one rotation, the reference edge on a slider will have moved the distance of one blade scale, okay, increment. So that's like 0.100, okay, and then go another, and then another, and all the way to, depends on the part size. And then the pointer is going to complete one rotation, okay. So one rotation of the pointer is going to be one blade scale increment, which is 0.100, okay. So one round, in other words, just one round, okay, is equal to this tiny little increment, which is your, okay, your blade scale, okay. So you know that measurement is actually equal to the entire measurement. So now we can see very clearly, right? So if you look at it from here to here, it's impossible to see, right? It looks like very, very small, but we can diverge it by using this dial. So we can be able to go into details, yeah? Measurement by doing this way, okay? First, we're going to put the part, right? So this is we're measuring inside, yeah? It looks like a little round part, and we're putting it in between the outside measuring faces, okay? So we have a two diameter. One is a inside diameter and the other one is outside diameter, because this is a pipe section which is empty inside, yeah. So your material, there's only this much of material. So in order for us to get the outside diameter, we're going to use outside measuring faces, put it in between them, yeah, and then of course adjust, yeah, the slider. And we're going to look at the blade scale, and here is your reference. So you're going to read it from 0 to the end of that reference, and you're going to get the blade scale. Then we will go into the second scale, yeah. So first you write down the blade scale is 1.00, yeah, because 1 inch, you can see it. From 1 to the reference, yeah, you will measure from here all the way to here, each increment, okay? And we call that the reference edge. And when you carefully look at it, that's like 1, 2, 3, about 4, okay? So we're gonna write 0.4, yeah. Then we're gonna get into the pointer, which is in the dial, and to read the 1,000, okay? How many thousand it is pointing to, and we saw it's about like a 0.037, okay? Almost 0.04, yeah. So we just say like it's 0.0 and then 3, because this each one of them is 0.01, 0.02, 0.03, and of course this we you can see it on the image, but you can see it outside, yeah. It's about 7, right? 0.007. So we our measurement for this part is we have to add everything up all together, and you get 1.437, okay? So the outside diameter is 1.437 inches, your pipe section. And then we have an Excel review, and I'll put it up, this Excel file. You can download it as many times you want if you mess it up. Go in there, and it's already programmed. All you have to is just a review of your TEK 101, okay, which is your prerequisite for this class. Make sure you do the homework inside of the Excel, and of course submit it along with the other lab exercise. And this, all of the exercise for Excel and the lecture exercises will go into quiz, okay? So now let's take a look at the real dial caliper outside, and you can see the dial is here. Your inside, okay, measuring surfaces right there. And here, this is your dial lock screw, that's your dial, and this is your slide thumb screw, and then this one is your slide lock screw, okay? So you can be able to use both of them to make sure where your measurement is going to stop, okay? Otherwise it's going to slide and your accuracy is not going to be very good. And this is of course your English dial caliper, and this is your metric dial caliper, and this is your outside measuring faces. And you can see these are the parts of a dial caliper. And these screws, again, of course, your dial lock screw is going to lock the rotation of the dial, and then the slide lock screw is going to lock your slide. Okay. As we go into this English dial caliper, we can see the marks. See, so for English, you have each mark is 0.1 inch, so that's 1/10 of an inch. And when you look inside of the dial, you're going to see each small mark on the English dial caliper is about 0.001 inch. Okay, so that's 1/1000 of an inch. Okay, then here's your metric. So each mark is 1.0 millimeter, and here for the dial part, each mark is 0.02 millimeters. Okay, so 1.0 millimeters, and this one is 0.02 millimeters. So that's a 1 whole millimeter, and that's 2/100ths of a millimeter. Okay. Okay, how are we going to use it? So in your lab, we're going to prepare. First, we always do, we clean the part, right? Use a wipe or solvent with a paper, and you can clean it. Clean is very important for precision and accuracy. You're going to clean the measuring surfaces on the caliper, and then you're going to loosen the clamp screw so you can slide, okay, to put the parts. And the dial, of course, the dial screw, okay, that I just show you, so you can be able to move that slide, okay, back and forth, and then close the slide to completely tighten it, okay, with the clamp screw, and you're going to adjust. So this is called the calibration. We're calibrating it before we use it, and you have to adjust that dial to 0, okay, when measuring faces are close to each other, close, and you gotta tighten it up so we get the 0, okay, the initial 0 correctly. So make sure you tighten the dial and about the screw, and then loosen the clamp screw so the slide, okay, can move after calibration. Making a measurement with the clamp screw loose, you're going to roll the thumb screw, okay, and then open or close the drawer. So if you have to go back here on the very first, right, and this is the thumb screw, okay, and this is your dial screw, and here's your slide screw. This is a 2, okay, screw you're going to use to slide back and forth and to hold the object of measurement and position, okay, and then you're going to close the drawers gently on the part. Don't use a force, okay, too much force. You're going to distort that caliper and you won't get accurate measurement. You can rock the caliper angle very slightly gently, and then slowly, and then you're going to apply, okay, pressure, okay, slight pressure, just a gentle pressure on the jaw to make sure you're getting the minimum reading, okay. Some people use a lot of force, and you shouldn't do that. Just go very gentle, and then when you have to stop, when your parts are in position in between these surfaces, then just gently, okay, stop there. You can of course always gauge, meaning do the calibration if you feel like your caliper isn't measuring or giving you the correct reading. You can always use a gauge block to make sure that you get the right measurement, okay. It's just a part of calibration. Okay, for cylinders, position like this is better. So it's going to give you your minimum reading, but if you position your object angle to the plane, you're going to get a very big error. Okay, so just be comfortable with the caliper. Don't just go in and start measuring the parts. So make sure how you can be able to control your instrument before you measure the parts. So just play with it, okay? Play with the slider, play with the screws, and then play with the calibration, okay? Before you jump into the measurement. So you might want to, it's a good practice to measure the gauge block, okay? So you know that your caliper is reading correctly before you jump right into the parts. Okay, so something like this, very confusing reading. So when you have like a, for this side of the scale, the references right here, yeah. So when you have something like this, you can barely see the 7, and you can really see the mark. See that? So the mark is on this side under the reference edge. So it's better that you stop at 0.6 instead of 0.7, okay? Or your error is going to be very bad. And then we will take care of that part by using the dial scale here, yeah? So the reading is 0.694. See how very close, because when you get to here, that would be another increment, okay? Okay, so here you can see the 7, but you're not so sure where that mark is, either on the reference, okay, or is before. So we can look right here in the dial, see how different it is. It is beyond, see, 0. Look at this example. Even though we can't see it, we have no idea what that mark increment for 7 is, okay, because this reference blade is coloring the mark. So we have to just check this and see this little pointer is before 0, so we take 0.6. And this little pointer is after 0, see? So we take 0.7 safely, okay? So the reading is 0.703 inch in this case. The same thing for 8, yeah? You can see it. So we're going to check this before 0. So we're going to just take 0.7, and then we're going to take care of the rest with the dial scale, which is 0.081, and add it up so you get 0.7, okay, 81 inch. And here we go again. So you have metric, you have 16 and 17, and you're not sure whether 17 is on or not. We look at the 0 before the 0, so therefore we're going to take 16 and then 84, okay, so 16.84 millimeters. Then the next one, the same thing, we can see it. It looks like 7, right? But we have no idea whether you should take 7 or not. So we look at the dial, and we see it's way past 0. See? So therefore we're gonna take 7.52 here. Yeah, 52 millimeters. And the last one, we have about 16, but you have no idea whether you should count 16 or not. We're going to check this dial scale, and you're going to look at this pointer, okay? And you see the pointer is right after, okay, the 0, right after this 0. So we're going to take line 15 and then 0.90, and we won't count 16, okay? You can also use this, yeah? So if you go like from here to here, you can use this one as right before the 0, so we can take 15 instead of 16. Okay. All right, that's it for Lab 2 lecture.